Alright, what you see here is different devices but with LCD displays. This LCD displays is used to show or display the current conditions of their own operations. For example, like this one, it will show the temperature set by the user for this air condition, and also the mode. And this one here for the calculator, as usual, we know it is to display the numbers and also the operations that we use. And we have the basic display here, which use 7 segment display. As you can see, there's 7 segment LCD to just display the values, and also these phones here also to show the phone number and so on. So this is the basic LCD displays, yeah? And besides these LCD displays, the black and white displays, we also have this, for example, on this robot here, with this RGB display that can show the values or the data in color formats instead of just black and white. And besides this basic display, we can also have different displays with different colors display, like these mobile phones here, and also your computers and the televisions. So these are all basically is being made by just a single by just a LCD display. So here in this video, I will show how you can actually program your Arduino so that it can display the data into the LCD, the basic LCD that I shown in these devices here. And again, if you would like to know how to do that in your Arduino project, so please watch this video until the end. This is what we're going to use in this tutorial here, which we will use this LCD here, which we call a 16x2 LCD, which will have 16 columns, which you can write 16 characters on it, yeah? And also it also have 16 times 2 rows, yeah? So you can write 16 character in one rows, and another rows also 16 character. So but before we continue, please check that you have, let's say if you have bought an LCD display, please make sure that, let's say if you bought this one without any header, so you need to buy this header pins here and solder it on this LCD display so that it will become like this. Then you can use with the breadboard that we will use later. So actually with this, you can easily, with this header, you can easily connect your LCD with the breadboard later. That's why the best thing is you buy this header pins here so that you can solder it and then you can easily connect with your breadboard later. Now let's move on to the circuit construction. Let's open up this Tinkercad, or if you don't have Tinkercad or you don't want to use Tinkercad, you can follow these connections here and directly construct your circuit on breadboard by using these circuits here, or by referring to this circuit here. But before that, I will explain one by one on each of the pins here. What does it mean by these pins here? Yes, and why it is connected like this. So first is the first pin at the end of the LCD is the ground and VCC. So obviously this is for the power. So VCC will be connected to the 5 volts power, and then the ground obviously will be connected to ground. And then we have this VO, or sometimes it refers to VEE. And what else? VO, VEE, and sometimes VSS, I think. Yeah. So again, the third pins here is basically to control the contrast of the LCD. So you can connect like this, meaning that you can connect to this potentiometer if you want to adjust the contrast of the LCD. But let's say you don't want to adjust the contrast, you want to make sure it is at the highest contrast level, so you don't need to connect to this potentiometer here. But what you can do is you can directly connect to the 5V power supply as well. In other words, this potentiometer here is not compulsory. You can, if you don't have a potentiometer, you can remove the potentiometer totally and connect this VO to the power supply, the 5V power supply. So that is to control the, again, to control the contrast. And then we have this RS. This RS. So RS is basically the register. So the register select ports. So this register select ports here, this register select port here is basically will produce what we call a pulse to set whether it is a data that we want to display to the LCD or instruction. In other words, it will change between high and low. When we like this, we connect it to the pins number 12. So this is actually any pins you want to connect it. It's up to you, but here in this example here, it is connected to the pin number 12. Why pin number 12? Again, these pins will change the states high and low if when we send a command, send a instruction to the LCD, which for example we want the LCD to clear LCD, so it will set the output to be low. So that is for instruction. And for the data, then it will set high, which means if you just want to display the data to LCD, it set the pins pins 15 just now, pins 11 just now to the high. So again, pin 12 here as high. So this is how this RS ports is done, or basically how this RS is functioning. So which means high, it's set high when we just want to display data, and it's set low when we want to give instruction to LCD to clear LCD, for example, to go to the next lines, to go to the next columns. So when we want to instruct the LCD, then we use this, then it will transfer RS value here to become low. So this is automatically done, but make sure you define it in your coding. So which parts is your pin 12, which parts is your pin RS. So if you don't define it correctly, so it can't operate correctly. So that is the fourth ports, which is RS, register select. And then we have this RW. So RW, read or write ports. So again, the name actually has already defined it. So read, meaning that we want to read from the LCD, and then this LCD will give instruction to the Arduino or the microcontroller. If we want to set it right, so when it's set right, then from the microcontroller it will write on the LCD. And since this tutorial is basically to write data to LCD, then we just set it to right. And how to set it right is simple. Basically, we set the pins here as low. So low is basically from a microcontroller to the LCD, and that's why, as you can see, it directly connect to the pins ground. Because of this, because we want to make it low for all the time. So if you want to make it to control the microcontroller from the LCD, is basically the other way around. So it will be high, so you will connect this to the power supply. So this is for the RW. So again, low to read, to write data to the LCD, high to read data from the LCD. And then the pin E, or enable. So pin enable is basically similar like the RS. It will send pulse, to enable the LCD or disable the LCD display. That's it, and that's why we connect it to any of the digital ports so that it can send this pulse whether high or low. Yeah, as simple as that. And next one is the DB0 until DB7. So DB means data bus, data bus from 0 to 7. So you can see here we only connect these 4 pins only. Why? Because we just want to send 4 bits data only, which means if you only have or you want to display only 4 bits of data, you only need these 4 pins only, DB4 until DB7. Don't make a mistake, don't use DB0 to DB3 but DB4 to DB7. If you have 8 bits of data, which means again you need to connect all of these pins here. So 4 bits is just 4 pins, 8 bits is all from DB0 until DB7. So remember this correctly. Again, this tutorial is only for 4 bits, and that's why we only use these 4 pins here. And finally, these 2 LED, which is one is anode and one is cathode, and as usual we know cathode will goes to the ground, and that's why cathode goes to the ground, connect to the ground, and the anode will connect to the power supply, and that's why it goes to the power supply. And that's it. This LED basically just to control the backlight of the LCD. So if we don't supply the power at the anode terminal here, so your LCD will be dim. If you want to have a maximum brightness of the LCD, make sure you connect this correctly. Make sure this part here goes to the ground, the cathode goes to the ground, and the anode goes to the power supply. That's it. That is the pins for the 16x2 LCD display. But as you can see here, this is for those who get this kind of LCD display. You can see here we need 1 2 3 4 5 6. So if you have 4 bits of data, 6 digital pins you need to use for just for this LCD. So let's say if you have button switch, if you have digital sensors, if you have any LED, you might have already used all of these ports here, which means that your ports in this Arduino might not be enough for your project. And that's why I am not usually use this LCD here, but instead I will use this LCD, the same LCD as you can see, nothing different, but the only difference here is basically I use it with this what we call as I2C module. So the I2C module. So let's say if you already bought this LCD without which is not soldered yet, so you can buy this I2C module here, and then solder it on this LCD here, and just follow this. Basically you can snapshot this video frame here and to see how you can solder this I2C module to your LCD. But if you already buy this this LCD here, which have already soldered here, you can use it separately on the breadboard. If you have already got this one here, you can solder it like this, with these pins here is at the pin number 16 size, and the ports, the connection ports will be at the pin number 1. So you can follow, you can screenshot this video, or you can pause this video if you want to see how you can solder this I2C module here. This is actually my personal favorite. Why is it? Because actually when you already done this, the outputs from this LCD is just only these 4 cables only, which these 4 pins here is basically 2 of the pins is ground and VCC, the power supply. So VCC, as we know, since it is a power supply, so we connect directly to the 5 volts ports, and then we have the ground, which connect to the ground. So the only two pins that will be connected to your Arduino board is these two, the SCL and SDA, as serial clock and serial data lines. Serial clock lines and serial data lines, so which will be connected to the serial SCL ports for this Arduino Uno. So how to know the SCL ports of the Arduino Uno? So basically you can read their data sheet, but I will show it here as well. So here, as you can see, there is SCL and SDA. So SCL is pin 5 and SCL is pin 4. So SDA is SCL is pin 5, SDA is pin 4. So SCL will goes to pin 5 and SDA will goes to pin 4. So that's it, as simple as that. So for those who have this I2C module here, you can directly connect to your Arduino by following this figure here. And again, you may pause this video as usual anytime you want if you need time to connect your circuit or connect your LCD display. But if, let's say, if you don't have this Arduino Uno for this, for those who get the Arduino Nano, so Arduino Nano is also the same. This is the pins for the Arduino Nano. So the SCL is also at the pin 5 and the SDA is also at the pin 4. So similar like the Arduino Uno, so you can just use this as your guideline. For those who use the Arduino Mega, the same thing, just find the SCL and SDA. So the SCL is basically, and SDA is basically at the PD0 and PD1 here, and then another SDA and SCL ports is at the PD0 and PD1 here, or the pin 43 and 44 here. And it is similar to anything. Let's say if you have Raspberry Pi or anything, or any other Arduino, Arduino Mini, Arduino 101, Arduino what else, and many more, and any Arduino that you have, the same thing. You just need to search for the SDA and SCL ports and then just connect it like I've shown in the figures here. So this is how you connect this if you have this LCD with this I2C module here. So again, you may take your time to connect your LCD, but if you don't have the hardware, again, you can just use this. You can just use this guideline in this Tinkercad here for those who don't have the I2C module. So you can follow this one. Again, in this Tinkercad doesn't have this I2C module. So if you want to simulate using this Tinkercad, so this is your circuit. But the best thing is you use the hardware here, and for those who wants to buy, who don't have this I2C module, you can buy it from anywhere that you find. One of it is this Shopee platform. This is not a promotion to Shopee. I did not get anything from them. Hopefully I can get it since I promote it here. So here, for example, like this, the price here is just about 3 ringgit only. So it is not expensive. Just a cheap component. So if you would like to get this, especially if you have a lot of inputs, a lot of digital inputs or output for your project, for your Arduino project, it is best to get this one, especially if you have the money to spend, since this is only 3 ringgit only. So you can get one and then solder it like I've shown previously, and then you can connect it using this circuits, using these figures here. So you may take your time to construct it. Again, for those who don't have hardware but wants to follow this tutorial will focus more on this I2C module instead of the normal construction that I shown in the Tinkercad previously. Although I will show a little bit the coding on this construction, but this will not be my main focus, which means I will more focus on the I2C module. But don't worry, you can still follow this video because most of the coding after that is similar, only the library is different. So which means you can still follow this tutorial by following this circuit here. For those who don't have the I2C module, for those who have I2C module, follow this circuit here. For those who don't have any hardware and want to follow the I2C module tutorial, you can use this Proteus software to simulate it. So this is the LCD, as you can see here, the connection for the LCD, and I connect with this, what we call the I2C module just now. So this is the I2C module for the Proteus, which you can search in this parts, here. Just search the PCF 8574. So which you will find this I2C IO. So use this one here. So this is what you will use, and then okay, and drag it in your circuits and connect it as what you've seen in this circuit here. So any medium you want to use, if you want to use Arduino, you want to use Proteus for simulation, so this is the connection that you can use. If you want to use Tinkercad, Tinkercad doesn't have the I2C module, so you need to use this construction. And if you want to directly use hardware, so this is the connection to the hardware. So now you can go and construct your circuit by using any of the methods shown here. And again, complete the circuits in this video, and I will see you again in the next video where I will start showing the programming. So this video here, I will stop here for now, and after you complete your circuit, don't forget to go to the next video. Again, as usual, stay safe, stay curious, and stay joyful. I'm Ihwan. May God bless you. Assalamualaikum.